This is mole to particle and particle to mole conversion. But before we start this calculation, we first of all have to understand what mole is. What is a mole? If you don't know what mole is, I'll advise you to watch Introduction to Mole by Tyler DeWitt. It's a very good video. Please watch it before you really get into this calculation. It has a very clear introduction to mole. So mole is like a dozen. A dozen is 12, equal to 12x, and the mole is 602 times 10 to 23 things. In chemistry, we refer to it as 1 mole equal to 6.02 times 10 to 23 representative particles. Then what is particle in chemistry? Representative particles refer to atoms, molecules, and formula units. When we use atoms, we are talking about smallest unit of element. When we use molecule, we are talking about smallest unit of covalent or molecular compound. When we use formula units, it is smallest unit of ionic compounds. Each of these refer to particles. Mole is the SI unit that measures the amount of matter a substance has. Scientists use moles as a unit of measurement. And this mole, which is 602 times 10 to 23 atoms, is Avogadro's number, named after an Italian scientist. So the Italian scientist is Avogadro. This Avogadro number is named after him, and the number is 6.02 times 10 to 23 atoms. We use mole to count atoms. Okay, we use mole just like we use dozen, we also use mole to count atoms. If we say 1 mole of helium is 6.02 times 10 to 23 atoms, what is 0.5 mole of helium? It's half of that. So you divide by 2, that will give you this. Okay, just to give you an idea of how mole is used. Let's look at an example of how to convert from particle to moles or mole to particle. How many molecules of water are in 0.360 moles of water? Again, we think about dimensional analysis. What's the relationship between moles and molecules? Any direct relationship between moles and molecules, if there's any direct relationship, is one-step problem. So we look at the equivalent statements. And here we go. 1 mole equal to 6.02 times 10 to 23 molecules. So we do not know, we know moles, we do not know molecules. So the equivalent statement is 1 mole equal to 6.02 times 10 to 23 molecules. Now, what is the conversion factor here? We put it in fraction form. 1 mole all over 6.02 times 10 to 23 molecules, or 6.02 times 10 to 23 molecules over 1 mole. Now, our strategy is we are going from moles to molecules using 1 mole equal to 6.02 times 10 to 23 molecules. Then we solve, we want to figure out the molecules. So what we know must be on top, numerator. And then this unit will be repeated here. We want molecules. So the which conversion factor is 6.02 times 10 to 23 over 1. And that will give 0.360 times 6.02 times 10 to 23 molecules, which will be equal to, try to use your calculator, to be 2.17 times 10 to 23 molecules. 3 significant figures. That's example of, here we went from moles to molecules. Moles to molecules. Let's look at this practice question. How many moles of magnesium are in 1.25 times 10 to 23 atoms of magnesium? Again, we underline what we know. We don't know the atoms. We don't know the moles. So we have to figure out the moles. So any direct relationship between atoms and moles? Yes. So it's one-step problem. Equivalent statement is 1 mole equal to 6.02 times 10 to 23 atoms. Okay, then conversion factors. 1 mole, you put the equivalent statement in fraction form, that's all we're doing. 6.02 times 10 to 23 atoms, or 6.02 times 10 to 23 atoms over 1 mole. Then the strategy, we are going from atoms, the unit of what we know, to moles. So using 1 mole equal to 6.02 times 10 to 23 atoms. So we want to figure out the number of moles. So we know, write what we know as a numerator, atoms over 1. Then we repeat the same unit. And then we are going to moles. We write the same unit so we can get rid of this because we want the moles. So now this is the conversion factor we use. Then this and this will cross out. That will give us 0.208 moles. Now we converted from atoms to moles. Let's look at more practice questions. The first one, how many atoms are in 0.750 moles of zinc? How many moles are in 9.03 times 10 to 23 formula units of sodium chloride? How many molecules are in 2.50 moles of carbon dioxide? Pause the video and try this on your own. Let's look at these practice questions together. Hopefully you've tried it. The first one, how many atoms are in 0.750 moles of zinc? So we know the moles of zinc, we don't know how many atoms. So we look at the equivalent statements. Any direct relationship between mole and atoms? Yes, right here. So the equivalent statement is 1 mole equal to 6.02 times 10 to 23 atoms. So the conversion factor will be 1 mole over 6.02 times 10 to 23 atoms, or 6.02 times 10 to 23 atoms over 1 mole. Then this is conversion for this strategy will be from moles to atoms using 1 mole equal to 6.02 times 10 to 23 atoms. Now, we want to solve for atoms, which will be what we know over 1, then, okay, we have atoms here. So the equivalent statement that we go is this one, 6.02 times 10 to 23 over 1. So this crosses out. This will give us, we multiply everything on top. The answer will be in atoms, and that will give us 4.52 times 10 to 23 atoms of zinc. Hopefully you got it right. Hopefully you got it right. Now, the second question is, how many moles are in 9.03 times 10 to 23 formula units of sodium? I think I have to divide this into, I don't think I have a lot of space, but I'll try. Formula units and moles, formula units and mole, here we go. So the equivalent statement will be 1 mole equal to 6.02 times 10 to 23 formula units. This ionic compound, because we're talking about sodium chloride. So that will be 1 mole over 6.02 times 10 to 23 formula units, or 6.02 times 10 to 23 formula units over 1 mole. That's our conversion factor. Then we continue here. The strategy will be, we are going from formula units to moles using 1 mole, 6.02 times 10 to 23 formula units. Then we set this up, it will be, we are solving for what? How many moles? Okay, this will be moles. So we know 9.03 times 10 to 23 formula units over 1 times formula units again. Mole on top. 6.02 times 10 to 23, then 1 mole. This will cross out. The answer will be 1.50 moles of sodium hydroxide, sodium chloride, I mean. Sodium chloride. That's it. Hopefully you got it right. There's remaining one question I gave you. I'll give you the answer for that one. Let's see. So the question number 3 is how many molecules are in 2.50 moles of carbon dioxide? So I gave you the answer to that one. Hopefully you get it right. Okay. That's it. I hope you're able to solve it. Thank you.